All right, guys, let's in part 3 of the stoichiometry trio, this trilogy. Let's just look at the stoichiometry problem solving flowchart. Now, this flowchart will also be posted to the Power School assignment, a PDF of this. But I'm going to kind of go through a few of the problems that we've already done and kind of how to follow along on this flowchart to help plan out your stoichiometry problem solving. So if you took notes on the 6 problems that we did, let's go back to problem number 1. In problem number 1, we started out with moles of iron. And so that would be moles of A. And so on your flow chart, you would start out here. Then once you have moles of A, as we've talked about in the other videos, once you have moles of A, you're on your way because you can then apply the mole ratio, which is always the coefficient of B over A. When you're done applying the mole ratio, you end up with moles of B. And then in that problem, we wanted to find grams of oxygen in problem number 1, sample problem number 1. And so we wanted to go here to mass of B. And how do you go to mass of B from moles of B? You use the molar mass, and we saw that we multiplied by the molar mass. In problem number 2, it was a mass of A to mass of B stoichiometry. So on the flow chart, you would locate mass of A to help plan out your attack. And then we need to, when you start out with mass of A, remember the first step is always to try to go to moles of A. To go from mass to moles, you would divide by the molar mass. That gets you moles of A. Then we apply the mole ratio, which gets you moles of B. Once you have moles of B, if you want to find mass of B, once again, you multiply by the molar mass of moles of B times the molar mass of B, and you get mass of B. Sample problem number 3, it was a mass of A to particles of B. So let's follow that on our flow chart. So again, if sample problem 3 was a mass of A to particles of B. And so let's follow how we need to what we need to do to get from here to here in our stoichiometry problem. Well, again, the first step, moles of A, you're on your way. And to get to moles of A, you would divide by the molar mass of A. Once you have moles of A, again, you apply the mole ratio, the coefficient of B over A. When you're done with that step, the units that are left are moles of B. Well, if you have moles of B and you want to find particles, well, what do? You go from moles to particles, Avogadro, and you would multiply by Avogadro's number to get particles of B. Problem number 4 was where we introduced volume, and we found volume using density. So it was a mass of A to volume of B using density. So what do? Well, mass of A, first step, always get to moles of A, divide by the molar mass. Once you have moles of A, the magic mole ratio gets you moles of B. And remember the way we said you solve a volume using density problem, you find the mass of B and divide by the density. And so from moles of B, you want to get to mass of B, again, multiply by the molar mass. And then to get that final step, that last step, volume of B, you divide by the density, and mass divided by density is volume. So that was the summary of problem number 4, mass of A to volume of B. All right, problem number 5 was a particles of A to mass of B. When you start with particles of A, you would start here on the flow chart, particles of A. Again, the first step is to get to moles of A. How do you get to moles from particles? You got it, Avogadro. Again, once you have moles of A, use the magic mole ratio, which will turn your problem, tilt your problem in terms of B. And now we wanted mass of B in problem number 5. So again, we're going to use the molar mass of B. Problem number 6 for the HChem guys was a mass of A to volume of B using the standard temperature and pressure, the molar volume. So let's map out mass of A to volume using the molar volume. Well, you mass of A again. First step, get to moles of A, divide by the molar mass. Apply the mole ratio, get your moles of B. Once you have moles of B, you apply the molar volume to get volume of B using that molar volume that we covered in Honors Chem. Now let's map out a couple other ones that we didn't do in the sample problems. Let's just make up a couple more and we'll follow those along on the flow chart. So let's say that we wanted to go from volume of A at STP, right? And we wanted to calculate particles of B. So if we want to go from volume of A at STP to particles of B, we would again use the molar volume to get moles of A. The first step is always get moles of A, but in this case we would have to divide by the molar volume. Again, once we get moles of A, we apply our mole ratio, we get moles of B, and to get particles of B from moles of B, we would use Avogadro. See? And finally, let's do one more. Let's say for some reason I started you off with volume of A using density. So we'll start here. And I wanted you to find mass of B. Let's follow that one on our flow chart. Well, to go from volume of A, you first need to go to mass of A. And the way volume and mass are related by density, in this case, though, you would multiply by the density in order to go from volume to mass. Once you have mass of A, again, the next goal, the main goal is to get to moles of A. We would divide the mass of A by the molar mass. Once we have moles of A, see, moles of A, you're on your way. Use the mole ratio to get moles of B. And since we want to end up with mass of B, once again, times the molar mass, we would get the mass of B. So again, this flow chart will be posted with the Power School assignment. You can use it to kind of map out your stoichiometry problem strategies. And hopefully this helped, guys. See you later.